Okay, on this example, I'm going to still need to start by getting the absolute value by itself. So I'm going to subtract 7 from both sides. Once I subtract the 7, I still have to bring down the -2 that was in front of that absolute value. It's still an x plus 1 inside the absolute value. The 7, of course, is gone. That leaves you with a -2 on this side. Then what I'm going to need to do now is I'm going to need to divide by -2. That's a little hard to show, but I'm going to go ahead and give you the result. So that's dividing -2 cancels out that -2 that's in front, leaving me with just an x plus 1. And then when I divide by a negative, I change the direction of the inequality. So anytime you multiply or divide by a negative, it changes it from a less than sign to a greater than sign. Then my absolute value is by itself, so I'm ready to split it into two equations. So the first equation is the x plus 1 is greater than 1. The other equation is the x plus 1, because the left-hand side does not change, is less than -1. Once again, just like on the last problem, when I change it, it changes from the greater than to a less than there, because I'm making that -1 a positive one. So when I rewrite the equation, that right side will not only change the positive negative sign anymore, it'll also change the direction of the inequality sign. Now to finish solving, I need to get x completely by itself. So subtract 1, and it's going to work the same for both of these equations. So I'll go ahead and subtract 1 there as well, leaving me with an x is greater than 0 for my first answer, and my other answer, part of my answer, is x is less than -2. Now technically, since the sign, once I got the absolute value by itself, not my original problem, but once the absolute value is by itself, since that was a greater than, this is technically an or. You can hear how greater than sounds a little bit like an or, but once again, we can figure this out from the graph without having to worry about that so much, because on my number line, I'm going to have a 0 and a -2. And I'll put a -1 line in between it just to make everybody happy. And then we can have an open circle on the 0 and an open circle on the -2. The reason these are open circles is I did not have an equal to with either one of those. So since neither one had a equal to under it, they were both open circles. Now for this one here, it's a greater than 0. You can see that sign's pointing to the right. So I'm going to go to the right of 0. This sign here is pointing to the left, so I'm going to go to the left of -2. So when I have two pieces of my graph like this, it's always an or situation, because there's no way to combine those two together. Being bigger than 0 is something totally different than being smaller than -2. There is no overlap. You can't put it together as a single statement. You have to leave it as an or. So on that last example with the and, those are going to be one piece of the graph that I could write as a single inequality sentence. But with the or, it's two separate pieces, going to have to say two separate statements joined by the or. And in my opinion, that's the easiest way to see the difference between an and or an or, is to see that the or is the one where the inequality is going two directions on the graph. Or if, on the other hand, if I had something like this on my graph that started here and went to some other point, I could say that that is an and, because I'm looking for the stuff that is between the two values. That could be an and, or it could actually be a between. If that was -2 and let's say 1, you could put the x between the -2 and the 1, or an and statement, either one. Hope this helps. If you got other questions, check us out in our Zoom session.